Today's show is sponsored by Smart. Stay tuned at the end of the show to learn how I'm using my interactive display to enhance my teaching. Episode 262, Simple Steps to Teach Kids to Program.
The 10-Minute Teacher Podcast with Vicki Davis. Every weekday, you'll learn powerful, practical ways to be a more remarkable teacher today.
Today we're talking to Aditya Batura, and we're talking about how to really get people excited about coding and interested. So, Aditya, you are the co-founder of Potato Pirate, which basically teaches 10 hours of concepts in 30 minutes. How can we condense down what we need to learn in coding to such a short period of time?
The whole point of learning programming, it just sounds so daunting because people have to understand the logic as well as the syntax. So the syntax is basically the makeup of the language. It's the grammar behind it. And unfortunately, in programming, that's just made up of mathematical jargon like parentheses, semicolons, colons, brackets, and like a lot of different symbols. And this gets a little overwhelming for people at most programmers who are just starting out, or anyone who's just jumping in to learn programming. This could be of any age, from a 6-year-old onwards up to an adult. The problem is that it's way too overwhelming for someone to grapple with the syntax in order to enjoy the logic that's behind it, the underlying logic. I mean, I'm a software developer by my formalized profession. Before I started doing all this, I'd say that I learned programming for the same reasons, and that's, I think, the main problem that people face. So instead of overwhelming people or any student with both the logic and the syntax at the same time, and mind you, the syntax for every programming language is different as it is for any spoken languages. Instead of overwhelming students with all this at the same time, we break it down and we just explain the computational thinking concepts, which are universal across all languages. Regardless of whatever you may be trying to program, you will have to understand the same computational thinking concepts, which is really the beauty behind programming, which is decomposition of your thoughts into lines of instruction.
I'll tell you this. So one of my introductory programming modules that I do with my students is just basic HTML. So many of the kids struggle, like you said, with the syntax and the spelling and that sort of thing. So how do you get past that? Is it more object-oriented? Are there challenges to do? How do we get past this syntax issue?
Nowadays, kids have it really good because there's so many visual-based, block-based learning platforms like Scratch and MIT's App Inventor platform, which basically allows you to build an entire program without actually having to write a single line of code or instruction, because you can drag and drop all of it and it fits in like a jigsaw. So firstly, you will know what fits and what does not fit in a certain block. Secondly, it's color coded. Thirdly, there's no syntax, so you don't need to worry about any of that. So there are a lot of block-based learning platforms for students or anyone of that, for that matter, to jump into and just, get their hands dirty and just push buttons and see how things work without being overwhelmed. Because back 5 or 7 years ago, you had to start out with the command line, and if you just missed out a semicolon, everything would just break, and you just get like this long line of failure message, and you wouldn't even know what it means. Right. So instead of having to do all that, now there's so many visual block-based learning platforms. But even with that, it seems like sometimes it's a bit disjoint and people don't really know what the starting point is. And that really was the motivation and the premise behind Potato Pirates, to try and provide a universal first step into the world of programming without having, for educators to set up the entire class or, get all the infrastructure set up, for any parent to get involved in their child's learning, by just playing this game. So both the parent and the child can pick up computational thinking concepts, and this can take place in any setting, in a classroom, outside, achieving all this without the use of a computer, that's really what we were trying to do. So just the basic fundamental underlying computational thinking concepts that don't hold you down to any language. And once you've played the game, you can proceed on to learning any different thing of your choice.
So this really fits with, if you can teach them the concepts, you can come back and teach the concept. It's funny, I recall a conversation I had, this has been several years back, but I had a friend from the very early days of computing. He was a bit older than me, and he actually learned how to program in ones and zeros. He programmed a machine language. And
Right.
do you know, he looked down upon what he called the modern programmer. I mean, this was, we're talking 90s here. And the modern programmer with arrogance, because he said, you guys aren't real programmers because the real programs are written in ones and zeros. Are there programmers, who have been taught classically, I guess with the brackets and all the syntax, who look at these easy entry type programs with a little bit of disdain and arrogance and claim that this is not how we need to be introducing computer science? Have you heard that?
Oh, definitely. I think there's always going to be proponents of both these views, but what I guess some people will always say that, but what we're trying to do is introduce it to a larger group of people. So we're trying to achieve breadth instead of the depth, if you know what I mean. Because at this point in time, I think every student, regardless of their background or wherever they are in the world, needs to at least have the basic computational thinking concepts, needs to have a basic understanding of what this word programming means, because I guess generation before doesn't really have that, and they didn't need to have that.
Yeah.
So, you definitely get those naysayers and, people who look at it with disdain because you're really dumbing it down. And, most of these people who say that are have been doing it, like you said, for years and years. So for them, they really had to battle, the good battle. And in fact, even for programmers nowadays, you don't get to go down into the ones and zeros, which is
they don't.
Unfortunate, actually. I've never programmed in machine language. The lowest or the closest to machine code I've ever gone is like probably with C or something, C language.
Yeah.
So I personally find a beauty in learning computer architecture from the ground up, which I have done, but most programmers nowadays don't practice that.
Well, and we're also talking about teaching kids in elementary, middle, and high school.
Exactly.
And personally, as a computer science teacher, I see that, when I start with Scratch, or even when I have my older students help younger kids an hour of code, I guess it becomes stickier. It becomes easier to learn when I do introduce those harder concepts, just because they understand what they're trying to do, so then they can learn how to do it.
Oh yeah, the objectives here are pretty different. Like what we're trying to do is, at this point in time, I think what we want is to get all kids excited about learning how to code and getting a buy-in from the students. So if you gamify the whole process and make it look less mundane, that really achieves that much better, right? I'm sure you must have noticed that in your classes as well. Getting a buy-in from students, getting them excited to want to learn more. Right, so that's deep learning, right? I mean, that's more conducive, which inspires students to want to learn more beyond the classroom. So, all these tools like gamification and all that really achieve that, especially for the younger students.
Okay, teachers. So we've really dug into, how to teach code to younger students, and really the focusing on the logic instead of the grammar and syntax. The name of the game is Potato Pirate. I'll include the link in the show notes as well. And I think this is an important conversation to have, but I smile because of thinking of my friend who was kind of looking down on the rest of the world because he, programmed in binary. We have to be careful as professionals not to think that the way we learned is the way everybody else has to learn. If we can improve the learning process, by all means, we should.
Yes, I totally agree with that.
This week, I'll be sharing the 7 pedagogical shifts that make interactive displays a key to a student-centered classroom on the Cool Cat Teacher blog, sponsored by Smart Technologies. Shift number 1 is that students are collaborators. My interactive display is the common workspace for the whole class. I use it as a digital workspace to display any screen for the whole class to see, as a large multi-touch drawing and brainstorming space, and so much more. My interactive display is a must-have device for me as a teacher.
Thank you for listening to the 10-Minute Teacher Podcast. You can download the show notes and see the archive at coolcatteacher.com/podcast. Never stop learning.